In today's video, we will be discussing point mutations. To demonstrate point mutations, let's observe this coding strand of DNA. We can transcribe this strand of DNA into a template strand and mRNA strand. The mRNA has the same sequence as the coding strand of DNA as it runs in the 5' to 3' direction. However, T's are replaced with U's. From here, we can use a coding chart to get the amino acid sequence. Although the human genome consists of 3 billion nucleotides, changes in a single base pair can have dramatic results. Point mutations are genetic mutations resulting in the insertion or deletion of a single nucleotide from a sequence of RNA or DNA. Point mutations can be classified by their functional effects. Missense mutations change a single nucleotide, resulting in a codon coding for a different amino acid. This type of mutation may or may not result in a loss of protein function. To demonstrate this, let's go back to the original DNA sequence. On the left, you will see the non-mutated strand, and on the right, you will find a mutated strand. When comparing the two, you can see that a transversion has occurred because a purine, G, was converted into a pyrimidine, C. In the original strand, tryptophan was produced, and in the mutated strand, cytosine was produced. Nonsense mutations exchange a normal amino acid codon for a stop codon, which will result in a protein being cut short and may result in a loss of function. Again, let's observe the original coding strand and compare it to a mutated strand. Observe the difference between the two strands. A transversion has occurred, causing a C to be replaced with an A. This exchange will cause the original amino acid cytosine to become a stop codon, which cuts the protein short. Silent mutations do not change the corresponding amino acid, and thus have no measurable effect on the protein produced. Here we can compare the original non-mutated strand to a mutated strand. Notice how a C is exchanged with a T. A transition has occurred since a pyrimidine has been replaced with another pyrimidine. In the end, both the mutated and non-mutated strands code for an amino acid, a spironogene. Readthrough occurs in translation when a mutation has caused a standard stop codon to be converted into an amino acid. This can be represented once again by comparing a non-mutated strand to a mutated strand. A transversion has occurred since A has been replaced with C. Rather than coding for a stop codon, cytosine amino acid is produced. The amino acid sequence, which was once stopped, can now go on.